Hello students, today we are going to discuss about surface chemistry. So, from the name itself you can understand it is a branch of chemistry dealing with the phenomenon that occurs on the surface or interface. So, in this chapter we are going to discuss about the chemical reactions that are happening on the surface. Hence, we have to know some terms that is involved in surface chemistry is adsorption, adsorbent, adsorbate, desorption and sorptions. So these are the terms that we will be frequently using in this chapter. So let us see what is it mean by adsorption. So adsorption is a process of accumulation of molecular species at the surface rather than in the bulk. So, surface chemistry is all about adsorption process. Hence, for adsorption to happen, you require an adsorbent. So, adsorbent is a material on the surface of which adsorption happens. Whereas, adsorbate means the molecular substance which accumulate at the surface of the adsorbent. Okay. So, for adsorption process to happen, there will be an adsorbent as well as an adsorbate. For example, when you are writing on the board, writing on the board, so the board indicates the adsorbent and the chalk powder which is put on the surface of the board indicates the adsorbate. Is it clear? So adsorbent and adsorbate. Now, the next term is desorption. The process of removing of adsorbed substance from the surface on which it is adsorbed is called desorption. That is, now the removing of. So if I erase this by using gesture, when I remove this is known as desorption process. So the adsorbed particles can be collected. Okay. Then the last term is sorption. So the process when both adsorption and absorption takes place simultaneously, we call it as sorption. So once again you can see here. So the black thing indicates adsorbent and the green substance accumulating on the surface, we call it as an adsorbate. So one more figure is over here where gas molecules are adsorbed on the charcoal. So let us now find out the difference between adsorption and absorption. So adsorption is a surface phenomenon happening on the surface only. So here in this diagram you can see it is happening on the surface. So the particles will accumulate only on the surface. Whereas absorption is a bulk phenomenon. It enters inside the adsorbent. Second point, substance is concentrated only on the surface of the adsorbent. Whereas in absorption, substance penetrates inside the adsorbent. So the substance will go inside the adsorbent for absorption to happen. Now, in case of adsorption, the rate increases rapidly at the beginning and gradually decreases until it attains an equilibrium, which clearly indicates that adsorption is a surface phenomenon. As far as the surface of the adsorbent is exposed to adsorbate, adsorption will happen. When the complete surface of the adsorbent is covered with adsorbate, further adsorption cannot happen. That is why the rate increases rapidly at the beginning and as time goes on, the exposed surface of the adsorbent decreases, it gradually decreases. Whereas absorption is a bulk phenomenon and uniform rate of reaction. So as soon as you put a sponge inside water, the water molecules go inside the bulk of the sponge. So it is a uniform rate of reaction. So here once again you can see this is absorption process. So the gas molecules are going inside the liquid bulk. Whereas this is the adsorption process. Liquid bulk is not at all entering the solid. It is staying on the surface of the solid interface. adsorption action. So usually adsorption actions are seen where drying of air in presence of silica gel. You might have noticed when you purchase any bottles or any flask from malls and all, inside the bottle you can see a small packet, that is a packet of silica gel. Why it is placed inside that bottle? To keep that bottle free from all moisture. Silica gel acts as an adsorbent over here. It absorbs water vapor and keep the bottle free from moisture, and therefore that bottle can be kept in the shops for a longer time. Then the aqueous solution of sugar is turned colorless by passing through charcoal adsorbent. You know that sugar is manufactured from sugarcane, the jaggery, which is brown in color, and to make it colorless, the solution is passed through charcoal adsorbent. Similarly, methylene blue dye is also turned colorless by passing through charcoal adsorbent. So these are the common examples we can see the adsorption phenomenon around us. So let us now discuss the mechanism of adsorption. Why adsorption happens on a certain surface? Why does this happen? So for that you should know first about the adsorbent nature. So if you see this layer of liquid over here, see the particle inside the bulb, here this particular particle is experiencing a balanced interaction between all the particles surrounding. So there is a balanced interactive force experienced by any particle inside the bulb. Whereas if you see a particle on the surface, see it is experiencing an unbalanced force. All three sides it is having an interactive force, but the fourth area is vacant. Therefore, this particle, the surface particle, is under a tension due to an unbalanced force. Okay. So what happens? The surface of solid liquid tends to satisfy their residual force by attracting and retaining the molecules of other species when brought in contact with them. So when a foreign object comes near it, these particles will have tendency to catch hold of them to satisfy their unbalanced force. So what happens? Hence, adsorption is an exothermic process. That is, when the adsorbate comes in contact with adsorbent, there is a small amount of energy, heat energy liberated. Delta H is negative. Then, obviously, when gas molecules are adsorbed, entropy of the molecule also decreases. Delta S is negative. And you know that for a process to become spontaneous, free energy change should be negative. Thus, for an adsorption process to be spontaneous, there must be a decrease in free energy. Delta G also should be negative. Okay. So you know the relation between delta H, delta S and delta G. Delta G is equal to delta H minus T delta S. And for a delta G to be negative, delta H has to be sufficiently high negative value, because minus T delta S is a positive value. This minus as well as delta S minus make this second term a positive value. So for delta G to be negative, delta H, that means the heat liberated should be large enough to overcome the positive T delta S. Okay. So as adsorption proceeds, delta H becomes less and less negative. When the surface exposed covers with the adsorbate, the delta H released will be less and less. Ultimately, delta H becomes equal to T delta S and delta G becomes 0. That is, equilibrium is attained. So equilibrium condition, that means when all the surface is covered by the adsorbent, where further adsorption doesn't take place, equilibrium is attained. Yes. Now let us discuss about the types of adsorption. So there are two types of adsorption. One is physical adsorption or physisorption. The next is chemical adsorption or chemisorption. So let's see what are the features of a physical adsorption. So physical adsorption arises due to van der Waals force of attraction, and they are not all specific in nature. For example, just now you have seen writing with a chalk piece on the board. That is an example of physical adsorption. You can write on the board by using a chalk piece or a crayons in it. So it's not all specific in nature and reversible. You can erase it, you can rewrite it. Whereas chemical adsorption is not like that. Another peculiarity about physical adsorption is usually easily liquefiable gases are adsorbed on it. Then enthalpy of adsorption is low over here. That is why when you write it on the board, you will not feel that temperature released out. Enthalpy of adsorption is low and stability decreases with increasing temperature. In case of physical adsorption, multi-molecular layers are formed. So these are the 7 peculiarities about physical adsorption. Whereas in case of chemical adsorption or chemisorption, it is caused by chemical bond. A chemical reaction will happen between the adsorbent and adsorbate and highly specific in nature. So for a chemical reaction to happen, both the adsorbent and adsorbate should have a reaction. So they are highly specific. Gases which react with adsorbent shows chemisorption, irreversible in nature. So once it happens, it cannot revert back. Enthalpy of adsorption is high. Huge amount of energy is liberated during adsorption. Stability increases with increasing temperature and only unimolecular layer is formed. So once it covers the surface of the adsorbent, again chemical adsorption cannot happen. See, you can see this example over here. So this is a picturization of physical adsorption. So once first layer is formed, again second layer can join with the first layer, then third, fourth, like that. Multi-layers can be formed. It is just a physical interaction, merely van der Waals force of attraction. Whereas in chemical adsorption, a chemical reaction is formed. You cannot form multi-layers. They form a type of bond with adsorbent. So physical adsorption or physisorption, chemical adsorption or chemisorption are the 2 types of adsorption process seen. Next, we discussed about adsorption isotherm. First, you should know what is an isotherm. So, it is a graphical representation of variation of amount of gas adsorbed with pressure at constant temperature. Okay, so how much amount of gas can be absorbed by applying pressure when temperatures get constant? The study of such experiment, when expressed in graphical plot, we call it as an adsorption isotherm. So one such adsorption isotherm is Friendlich adsorption isotherm. In Friendlich adsorption isotherm, detailed study is not there for you in the syllabus. We shall highlight the points. Here, first let us discuss about the empirical relation given by the scientist Friendlich between the quantity of the gas absorbed in unit mass of adsorbent and pressure at a particular temperature, as x by m is equal to kp raised to 1 by n. Very, very important equation it is. Once again I shall repeat. Friendlich adsorption isotherm equation is x by m is equal to kp raised to 1 by n. So what is this x denotes? X is the mass of gas adsorbed on m mass of adsorbent at pressure P. K and n are constants and n can have value greater than 1. So this is the graphical representation. Now when x by m plotted against pressure, 3 graphs are being shown here at 3 different temperatures. So 2 observations can be drawn out from this particular graph. So first let us study about the the graph which is happened at 195 Kelvin, you can see that as pressure increases, the amount of gas absorbed also increases. But after particular pressure, the graph is tending to show parallel to y-axis, which indicates that the adsorption is independent of pressure. Similarly, in case at 244 Kelvin as well as 273 Kelvin, after a particular amount of pressure, it becomes parallel to y-axis, which indicates pressure is having no role on further adsorption process. Okay, the next thing you can study from this curve is that these curves indicate that at a fixed pressure, there is a decrease in physical adsorption with increase in temperature. So as temperature increases from 195 to 244 to 73, the amount of gas absorbed, physical adsorption, decreases with pressure. So these two are the observations we can see from this Freundlich adsorption isotherm. Now the logarithmic form of that equation. The logarithmic form of the equation is log x by m is equal to log k plus 1 by n log p. So this equation is a logarithmic form of Freundlich adsorption isotherm equation. Now this is resembling a straight line equation. So once when you plot log x by m against log p as shown here in the second graph, you will be getting a straight line, and its y-intercept will be getting log k, and the slope of the graph is 1 by n. Next, let us now explain the merits of this isotherm. Isotherm explains the behavior of adsorption in an appropriate manner. The factor 1 by n can have values from 0 to 1. Thus, equation holds good at a limited range of pressure. Now, if you put 1 by n 0, first condition if you put, you will be getting x by m is equal to constant. Adsorption is independent of pressure. Pressure has got no role, that is when 1 by n is 0. The next limit, upper limit, when 1 by n is equal to 1, x by m is equal to kp, where k is a constant. So x by m is proportional to pressure. Adsorption varies directly with pressure. So these are the highlights of Freundlich adsorption isotherm. But drawback or the demerits. Experimental isotherm always seems to approach a saturation at high pressure, or we can say that Freundlich adsorption isotherm fails at high pressure. It is only applicable for a particular range of pressure. Now, adsorption from solution phase. Previous we have discussed adsorption of a gas on solid. Now we are going to express Freundlich adsorption isotherm in case of solution phase. So here the adsorbent is solid, adsorbate is liquid. Extent of adsorption of liquid on solid depends on the increase in the concentration of solute in the solution. So if the concentration of solute increases, obviously adsorption of that solute on the adsorbent increases. Next, increases with the surface area of adsorbent. As you know that adsorption is a surface phenomenon. When you have a larger surface area, adsorption process will increase. Then decreases with increase in temperature. So if temperature is increasing, it will decrease. Hence, we can modify the equation as x by m is equal to Kc raised to 1 by n, where C denotes the concentration of the solute in the solution, and its logarithmic form is log x by m is equal to log k plus 1 by n log c. So let us now discuss some application of adsorption. The first one, the foremost one is the production of vacuum. To create a vacuum condition, The adsorption technique plays a vital role because even if after removing the gases by using vacuum pump also, to make it complete vacuum, usually adsorbing agent or adsorbent is placed in that to produce a complete vacuum condition. Then second, in gas mask. So especially people working in mining industries, while they dig inside the earth, the mask they wear is containing some small particles of carbon. Carbon acts as a good adsorbent. Hence, while they are going under the earth, when they come in contact with poisonous gases, it will not reach their nose. Instead, it gets absorbed on the mask. Then controlling of humidity, removal of coloring matter from the solutions, heterogeneous catalysis, it is very important in petrochemical industries, where reduction of chemicals takes place with the help of a heterogeneous catalysis. Usual catalysts are our platinum, palladium, etc. Then separation of inert gases. So from the mixture of inert gases, we can separate them by using adsorption technique. In curing diseases, froth flotation process, chromatographic analysis, etc. So these are the some common application of adsorption. Now we shall move on to catalysis. Okay, so catalysis is what we will discuss now, where adsorption phenomenon is worked. So before that, let us first know what do you mean by a catalyst. So catalyst is a substance which alters the rate of reaction and themselves remain chemically and quantitatively unchanged after reaction. Okay, so they are not going to take part. They just provide a platform for the reactants to react and increase the rate of reaction. And another substance known as promoters. These are the substance that is added during the catalysis process to enhance the activity of the catalyst. For example, in Haber's process of manufacturing ammonia, the equation is nitrogen plus hydrogen in presence of iron and molybdenum. Both are there. Here iron solid act as a catalyst, whereas molybdenum act as a promoter. Promoter helps the catalyst to increase its activity to give ammonia gas. There are other substances known as poisons. Substance that decreases the activity of catalyst are known as poisons. So promoters will increase the activity of the catalyst, whereas poisons will decrease the activity of the catalyst. So let us discuss now catalysis process. Catalysis can be divided into two groups. There are two types of catalysis process happening. One is homogeneous catalysis and second one is heterogeneous catalysis. Homogeneous catalysis, when the reactants, products and the catalyst are in same phase. So here the reactants, the catalyst, product all should be the same physical state of matter. Hence, it is very important. If you think in the examination point of view, if they ask the definition of homogeneous catalysis with an example, it is very important to mention the physical state of the reactants as well as the catalyst. Otherwise, marks will not be awarded. So here is an example: sulfur dioxide gas plus oxygen gas in presence of NO gas will give sulfur dioxide gas. Another example: hydrolysis of sugar. Here also, see, the sugar is in liquid state, water, liquid. Sulfuric acid is a catalyst which is also in the liquid. So in homogeneous catalysis, the reactants as well as the catalyst should be in the same physical state. Whereas heterogeneous catalysis means when the reactants and the catalyst are in different phase. Here also, while writing the example, it is very important to mention the physical state of the reactants and the catalyst. So for example, see, nitrogen gas plus hydrogen gas in presence of iron. Iron, the catalyst, is in solid state to give ammonia gas. Another example, see, sulfur dioxide gas plus oxygen gas in presence of platinum solid catalyst. In previous example here, it is nitric oxide gaseous catalyst, whereas here it is a solid catalyst. The product is same, but the physical state of the catalyst as well as the reactants are different. Hence, we are heterogeneous catalysis. Next, adsorption theory to explain the catalytic action. So, why we have included the catalyst topic under this heading? Because here, when you are undergoing a heterogeneous catalysis, adsorption phenomenon is happening. So, let us see how it is happening. So, it involves 5 steps. So, this is the mechanism to explain heterogeneous catalysis, not homogeneous. So, see, first is diffusion of the reactants on the surface of the catalyst. So, the reactants are spread everywhere. So, these should first come near the catalyst. Diffusion of the reactants on the surface of the catalyst. Step 2. Once they come near to the catalyst, adsorption will take place. Adsorption of the reactant molecules on the surface of the catalyst. Then, what happens? When they get adsorbed, the reactants will react. Chemical process will happen. Occurrence of chemical reaction on the catalytic surface to the formation of an intermediate molecule. So, first the reactants are coming and absorbing on the catalyst. Now, the two reactants will react in the presence of catalyst to form an intermediate molecule. Finally, once the product is formed, product gets detached. Desorption of the reaction product from the catalytic surface. They break the bond between the catalyst and the product. So, desorption of the reactant product from the catalytic surface. Finally, diffusion of the product away from the catalyst. So, we shall once again explain this by using this screen. So, this is the catalytic surface over here. Now, the reacting molecules are coming near the catalyst. Adsorption happens. So, the reactants A and B is getting adsorbed on the surface of the catalyst. They react on the surface of the catalyst to form an intermediate product. Finally, desorption of the product. AB is the product. They get detached from the catalyst and they move away from the surface of the catalyst. Now, this catalyst is ready to attract the new reactants on the surface and the process will continue. So, this is the adsorption theory of heterogeneous catalysis. Now, some important features of solid catalyst. First is activity of the catalyst. Okay. So, what do you mean by an active catalyst? So, an active catalyst depends upon the strength of the bond. So, a good catalyst should never make a weak bond nor a strong bond with the reactants. The bond between the reactants should be an intermediate between the. So, to be active catalyst depends upon the strength of the bond. An active catalyst adsorbs the reactants with the moderate bond and leave no space on its surface. So, complete surface is covered with the reactants and the bond formed should not neither be weak nor be too strong. For example, for hydrogenation reaction, the catalytic activity increases from group 5 to group 11. So, group 5 to group 11 belongs to D block or transition elements. So, they act as a good catalyst for reduction process. So, during reduction process, we are selecting the catalyst present in between this group. Because when hydrogen gas and the reactants come near to this catalyst, they form a bond which is of moderate strength. Because after the reaction, product should detach or desorb from the catalyst and move away. That is known as an activity of the catalyst. Next is selectivity of the catalyst. So this is very, very important. Here, the selectivity of the catalyst means, see, previously we told that catalyst cannot alter the rate of reaction, but cannot change the product. But there are cases where, depending on the catalyst used, the product also changes. So selectivity of a catalyst is its ability to direct a reaction to yield a particular product. For example, very important, see, in all three examples, here we have carbon monoxide and hydrogen. But the catalyst used in three cases are different. In first case, when nickel catalyst is used, it is undergoing normal reduction process. Removal of oxygen, addition of hydrogen, we are getting methane plus release of water. Whereas, when we are using copper in presence of zinc oxide and chromium oxide, this combination, combo pack of catalyst, same reactants, carbon monoxide and hydrogen, both are gaseous state, we are going to get methanol, CH3OH as the product. Whereas, if you use only copper catalyst with same reactants, carbon monoxide and hydrogen, we are getting aldehyde, it is methanol. So, three different products are obtained from the same reactants with same physical state when catalyst is different. So, this is a particular example where you have to think about the selectivity of the catalyst. Then, in selectivity, there is another one category known as shape selective catalyst. The example of shape selective catalyst is zeolites. So, here the catalytic reaction is completely based on the spore structure present in the catalyst. The catalytic reaction depends on the pore structure of the catalyst, and the size of the reactants and the product molecules is called shape selective catalyst. So, for example, here this is a shape selective catalyst, zeolite. You already studied about zeolite in first year. So, zeolite widely used in petrochemical industries for cracking of hydrocarbon and isomerism. ZSM5 converts alcohol to petrol by dehydration process. So, the spore space is where the catalytic action happens. So, the reactant should have the shape that fits into this pore of the catalyst for chemical reactions to happen. And finally, product form will have different shape. It cannot happen, it emerges out. We shall see in detail today zeolites. So, zeolites are microporous structure composed of aluminium, silicon and oxygen. So, what are zeolites? They are aluminosilicates. So, it's a structure of zeolites. They have a cage-like structure which gives them a large surface area for absorbing reactant molecules. So, in this cage-like structures, the reactants will fix into it because of the shape of the reactant. The complementary shape of the reactant will fix inside the shape of this catalyst and this reaction happens. So, once it reacts, the product form will not have the particular shape, it comes out. Shape selective catalyst only on reactants with same size and geometry can be read here. Next is enzyme catalysis. So, what are enzymes? Enzymes are biological catalysts. Enzymes, they are protein molecules of higher molecular mass and form colloidal solution in water. They are also termed as biochemical catalysts. Numerous reactions that occurs in the bodies of animals and plants to maintain life process are catalyzed by enzymes. Okay, so enzymes are the biomolecules present inside the living organisms. There are so many chemical reactions happening in living organisms. If you consider the case of human beings, starting of the digestion process, it starts from mouth, saliva. In saliva, there is the enzyme known as salivary amylase, which help in the first digestion process happening in the mouth. Then it goes down to the food pipe, and all those processes of digestion you will be studying in your biology classes. But enzymes play a vital role over there. So, they are the catalysts. Here are some examples of the enzyme actions. So, example, enzyme invertase present in yeast will convert sucrose to glucose and fructose. Whereas, in the same yeast, enzyme zymase is present. Zymase will convert glucose to ethyl alcohol and carbon dioxide. Zymase cannot convert sucrose to glucose and fructose. Only the invertase present in the mixed. Highly specific is enzyme action. That is the point over here. Next, malt. In the malt, there is a diacetyl present, which converts starch to maltose. Yeast, there contains another enzyme of maltase, which converts maltose to glucose. Similarly, in soya bean, there is urease enzyme, which converts urea to ammonia and carbon dioxide. In stomach, what pepsin enzymes are there, converts proteins to amino acid. These are the few examples of enzyme catalysis process.